Hello, I'm Achit Nair from Nair's Aviation Ground School. This is the 19th video in a new series of educational aviation videos for the aspiring pilot. In our recent video, we had discussed the cockpit and the controls found within. In addition to the controls, the cockpit or flight deck is home to a variety of important instruments that provides the pilots with all the information needed during the phases of a flight. This video is about flight instruments. In our last video, we had discussed that the cockpit was the office of the pilot. Continuing with that analogy, if the cockpit is the office of the pilot, the flight instruments can be thought of as the office computers, where important information is given to the pilot, and where the pilot is able to find out more about the current situation of the flight. Flight instruments are the instruments in a cockpit of an aircraft that provide the pilot with information about the flight situation of that aircraft, such as altitude, airspeed, and direction. They improve safety by allowing the pilot to fly the aircraft in level flight and make turns without a reference outside of the aircraft, such as the horizon. The common flight instruments found in almost every aircraft in operation today can be split into different systems. These systems are defined based on the sources used by the flight instruments to provide information and readings to the pilot. The three major systems found in all aircraft are the pitot-static system, the compass system, and the gyroscopic or vacuum system. The pitot-static system contains the airspeed indicator, the altimeter, and the vertical speed indicator. The pitot-static system is so named because it derives the raw data used by the altimeter, airspeed, and vertical speed indicators from the pitot tube and static ports of the aircraft. The airspeed indicator shows the aircraft's speed, usually in knots, relative to the surrounding air. It works by measuring the ram air pressure in the aircraft's pitot tube relative to the ambient static pressure. The indicated airspeed, which is the airspeed shown on the indicator, must be corrected for non-standard pressure and temperature in order to obtain the true airspeed, or TAS. The instrument is color-coded to indicate important airspeeds, such as the stall speed, the never exceed airspeed, or the safe flap operation airspeeds. The altimeter shows the aircraft's altitude above sea level by measuring the difference between the pressure in a stack of aneroid capsules inside the altimeter and the atmospheric pressure obtained through the static system. It is adjustable for local barometric pressure, which must be set correctly to obtain accurate altitude readings. As the aircraft ascends, the capsules expand and the static pressure drops, causing the altimeter to indicate a higher altitude. The opposite effect occurs when descending. The vertical speed indicator is sometimes called a variometer, or the rate of climb indicator. The VSI senses changing air pressure and displays that information to the pilot as a rate of climb or descent in feet per minute, meters per second, or knots. The pitot-static system, as mentioned before, depends on the pitot tube and the static port for the raw data for the airspeed indicator, altimeter, and vertical speed indicator. Problems will arise if the pitot tube or static port inputs which are exposed to the elements are blocked or inoperative. Especially when flying in cold weather and high altitudes, the pitot tube and the static port can incur ice buildup, blocking the inputs and therefore impacting the pitot-static instruments in the cockpit. The instruments could become inoperative, or even more dangerously, indicate incorrect information. It is important to know how to mitigate the loss of some instruments by using the other available instruments. The compass system is used for the magnetic compass, which is found in all aircraft. The magnetic compass is often used as a backup device in more advanced aircraft with digital displays. The compass shows the aircraft's heading relative to the magnetic north. The magnetic compass is prone to many errors. Errors include variation, or the difference between magnetic and true direction, and deviation, caused by the electrical wiring in the aircraft, which requires a compass correction card. Additionally, the compass is subject to dip errors. While reliable in steady level flight, it can give confusing indications when turning, climbing, descending, or accelerating due to the inclination of the Earth's magnetic field. For this reason, the heading indicator is also used for many aircraft operations, but periodically is calibrated against the compass. The gyroscopic system, or the vacuum system, is used by the attitude indicator, the heading indicator, and the turn and slip indicator. These indicators use a gyroscope. A gyroscope is a device consisting of a wheel or disc mounted so that it can spin rapidly about an axis that itself is free to alter in direction. The orientation of the axis is not affected by tilting of the mounting, so gyroscopes can be used to provide stability or maintain a reference direction in navigation systems, automatic pilot systems, and stabilizers. The attitude indicator, also known as the artificial horizon, shows the aircraft's relation to the horizon. From this, the pilot can tell whether the wings are level, roll, or if the aircraft nose is pointing above or below the horizon, which is pitch. This is a primary instrument for instrument flight and is also useful in conditions of poor visibility. Pilots are trained to use other instruments in combination should this instrument or its power source fail. The heading indicator, also known as a directional gyro, or DG, displays the aircraft's heading with respect to the magnetic north when set with a compass. The heading indicator is used instead of the magnetic compass in most operations due to the error-prone nature of the magnetic compass. That being said, the heading indicator is also somewhat error-prone, but nowhere as much as the compass. Bearing friction causes drift errors from precession, which must be periodically corrected by calibrating the instrument to the magnetic compass. In many advanced aircraft, including almost all jet aircraft, the heading indicator is replaced by a horizontal situation indicator, or HSI, which provides the same heading information but also assists with navigation. The turn and slip indicator actually consists of two instruments in one. These include the turn and slip indicator and the turn coordinator, which indicate rotation above the longitudinal axis. They include an inclinometer to indicate if the aircraft is in coordinated flight or in a slip or skid. Additional marks indicate a standard rate turn, where the aircraft turns 360 degrees in 2 minutes. The major instruments found in the cockpit today date back almost a century. Developments in the field have been rare, but in the last 2 decades, there have been some advancement. Today, many new aircraft use a primary flight display instead of the older analog instruments. A primary flight display, or PFD, is a modern aircraft instrument dedicated to flight information. Much like multifunction displays, primary flight displays are built around a liquid crystal display, or CRT display device. Representation of the older 6-pack or steam gauge instruments are combined into one compact display, simplifying pilot workflow and streamlining the cockpit layout. Most airliners built since the 1980s, as well as many business jets and an increasing number of newer general aviation aircraft, have glass cockpits equipped with primary flight and multifunction displays, MFDs in short. Using the primary flight and multifunction displays together provides more information about the aircraft's performance, location, and status than the older instruments ever could. The primary flight display is the future of flight instruments. It is very important that the student pilot knows the functions of the flight instruments, as well as how to read and interpret the data provided by the flight instruments. Knowing the operation of the flight instruments will also help the pilot mitigate the failure of flight instruments, allowing them to safely continue the flight without any other issues. The flight instruments of an aircraft provide the data needed to successfully and safely pilot the aircraft. For more information, please contact us at liftanddrag@gmail.com and visit our website at nyersaviation.webnode.com. Thank you, safe flying!